Okay, so we're going to go through this note page and hopefully go over some of the questions you might have had when you tried it on your own. So on part A, we are solving these equations, and especially when we're solving equations with square roots, we always want to check for extraneous solutions. And remember, those were solutions that we get from solving. We did the solving correctly, but they don't make sense in our problem, right? It causes a domain error usually. So on part A, to get rid of our square root here, we're going to want to square each side, right? Because squaring is the inverse of square rooting. So on our left-hand side, we'll be left with 2x plus 3, and on our right, we'll be left with x squared. And so the goal here when we're solving a quadratic is to get a 0 on one side and everything else on the other. And remember, we talked about, we always want to try to keep the x squared positive because it's going to make it a little bit easier to factor. So let's move over the 2x plus 3. So we'll have 0 equals x squared. When we subtract 2x from both sides, we'll have minus 2x. And when we subtract 3, we'll have minus 3. Okay, so at this point, we can factor our quadratic. So we get x and x. Okay, multiplies to 3, adds to 2, well, 3 and 1, then we want it to be negative, so minus 3 plus 1. Okay, so our solutions here are x equals minus 1 and x equals 3. Okay, and so we kind of make sure that these answers work, and we got to plug both of them in. So I'm just going to erase this stuff just so we can see a little bit better. Okay, square root of 2 times the minus 1 plus 3, does that equal minus 1? Well, right off the bat here, I'm seeing something problematic. A square root, when the square root is already there, right, it's never going to equal a negative. Okay, so right off the bat, I can see x equals negative 1. That's going to be extraneous. Okay, let's plug in 3. Square root of 2 times 3 plus 3, does that equal 3? Okay, square root of 6 plus 3, square root of 9. Okay, so the square root of 9 does equal 3. So this would be our only solution here. Okay, on part B, same idea. If we want to get rid of this square root symbol, we need to square both sides. Okay, so on the left, we'll be left with 3x minus 5. On the right, we need to make sure we use our box method to multiply out x minus 5 squared. So on one side, we'll have x minus 5. The other side will have x minus 5. So we'll get x squared minus 5x minus 5x plus 25. Okay, so on the right, we have x squared minus 5x and minus 5x from our box combine to give us a minus 10x plus 25. Okay, same as before, we want a 0 on one side, everything else on the other. Since our x squared is already positive on the right, let's move the stuff over to the right. So we'll subtract 3x from both sides, add 5 to both sides. So we'll get 0 equals x squared minus 13x plus 30. And again, we want to factor. So we'll have an x and an x. We need something that's going to multiply to 30, add to minus 13. So right off the bat, I'm thinking minus 10 minus 3. Okay, so x equals 10, x equals 3. Okay, and same as before, whenever we're dealing with a square root symbol, we need to go back and plug in our answers to make sure that we're not getting solutions that don't make sense. Okay, so square root of 3 times 10 minus 5, is that going to equal 10 minus 5? Square root of 30 minus 5 equals 5, right? 10 minus 5 is 5. Square root of 25 equals 5, and that one's going to work, okay? So right now, we know that x equals 10 is going to be a solution. We do need to check x equals 3. 3 times 3 minus 5 equals 3 minus 5. Okay, so we get square root of 9 minus 5, square root of 4, and we get 2 is equal to minus 2. Remember when that square root is already there, we only get a positive answer out, right? This square root of 4 would not be plus and minus 2 because that square root is already there. And so we end up with 2 equals negative 2, which we know is not true. So x equals 3 is our extraneous solution here. Okay, moving on to number 2, we have a systems of equations word problem. So it says Grossmont High School is hosting its annual talent show, and you get a discount if you have an ASB card. Okay, like we talked about in class yesterday, we kind of need to decipher these paragraphs for important information. This first sentence is great, giving us context, but it doesn't really give us much information about our equations. Okay, so 2 tickets with an ASB card and 2 tickets without an ASB card cost $23.50. That's going to give us some information. Okay, 5 tickets with an ASB card and 3 tickets without cost $43.75. So the goal here is to figure out how much are tickets with and without. So we need to kind of decide on variables. I'm thinking I want to do a Y for yes has an ASB card and an N for no ASB. Okay, you can choose any letters you want. Those are just ones that are making sense to me in my head. But that's why it's important that you label your variables so you know what you're solving for. So first equation, 2 ASB card tickets and 2 tickets without cost $23.50. Okay. In our second equation, it says 5 tickets with an ASB card and 3 tickets without cost $43.75. And so this is kind of an example we didn't quite get to yesterday, where we have these 2 equations, right? They're not really set up in such a way that it would be super easy to use substitution. We could do that. But they're also not set up in a way that is really easy to use elimination. So what we're actually going to have to do is kind of think about multiplying both equations, right, to try to get some opposites. Right off the bat, I'm seeing this 2 and 3, and I'm thinking, okay, what if I could make those both into a 6, right? And then we'll be able to add them and cancel out our 6's. So if we wanted to make that 2n into a 6n, we would multiply by 3. If we wanted to make that 3n into a 6n, we'd multiply by 2, okay? One of those 2n's or 3n's is going to have to be negative so that they cancel. So let's just choose this equation to make negative. It doesn't matter which one, right? Just like yesterday. So let me go ahead and rewrite our equations over here. So we'll have 6y plus 6n equals, let me grab a calculator. Let's see, 2350 times 3, 7050. Okay, then we have minus 10y minus 6n equals 43.75 times that negative 2 gives us negative 87.50. Okay, so when we add our equations together, we're going to be left with a minus 4y here. Our n's cancel. And then we're going to be left with 70.50 minus 87.50. We're left with 17. Negative 17. Okay, so our y is going to be 425. Okay, so with an ASB card, it looks like the cost is 425. Okay, now we need to figure out the cost without an ASB card. Remember, we can go back to our equations, either one, and plug in our y. So we're going to go over here. So we have 2 times y. I'm going to do that first equation just because our numbers are a little bit lower. So 2 times 425 plus 2n equals 2350. Okay, so 2 times 425 is 850 plus 2n equals 2350. Subtract over that 850, so 2350 minus 850. 15. Okay, so our n is equal to 750. Okay, so if you have an ASB card, it's going to cost you $4.25, and if you don't, it's going to cost you $7.50. Okay, Really quickly, let's just go back and double check that those work. So remember, if we wanted to check our equations, we're just plugging in, okay, our, in this case, n and y into our equation. So in my calculator, I'm typing 2 times y, our y was 425. And I'm doing plus 2 times 750, because that's our n. Okay, that gave me 2350, but we also need to check that in our other equation. So 5 times 425 plus 3 times 7.5, I got 4375. So since our solutions worked for both equations, we know they're correct. Okay, number 3. So solve this equation graphically and label our solutions. So we're going to graph each of our equations separately. We're first going to graph our quadratic, and then we're going to graph our line. Okay, so I'm going to do the quadratic in purple. We know we have a vertex here at 2, -2. And we have no stretch. So when we go over 1, we go up 1. Over 2, we're going to go up 4. Okay. So I'll have a sketch like this. Okay. Our line, we have our y-intercept at 2 and a slope of -1. So when we go down 1, we go right 1. Down 1, right 1. Okay. So we can see that we're crossing through in 2 places. We're crossing through at 0, 2, and we're crossing through at 3, -1. Okay, so those are our intersection points. But remember, if it's asking us for solutions, it's asking us for x values that make this equation true. So the only solutions we're counting are x coordinates. 0 and 3 would be our solutions right here. Okay, solving it algebraically, I'm going to rewrite our equation. Okay, when we have x minus 2 squared, we need to do our box method. Oops. So we'll have x minus 2, x minus 2. So we have x squared minus 2x minus 2x and a 4. X squared, we'll get minus 4x by combining these two terms. Rewrite our 4 minus 2, and I'm just rewriting the rest. So same as before, when we're solving a quadratic, we need that 0 on one side of our equals. So let's move that -x plus 2 over. Okay, so we'll do plus x minus 2 minus 2. Okay, so we have x squared minus 3x. Okay, we have 4 minus 2 minus 2. Okay, we're left with nothing there, right? A 0. So we get this equation. Okay, we could factor, use quadratic formula, but we can also notice both of these terms have an x. So that's actually something we can factor out. So if we take out an x, x times x would give us x squared, and then x times minus 3 would give us minus 3x. So this is actually how it's going to factor. So we'll get x equals 0 and x equals 3, just like we did when we were graphing. Okay, moving on to the next one, solving this absolute value equation. The very first thing we need to do is get our absolute value all by itself. And so what we need to do is subtract 2 from both sides. And then divide by -5. So if we have this absolute value equal to 25, remember there's 2 ways we could get that. We could either have a positive 25 on the inside, or we can have a negative 25. Either of those, when we take the absolute value, are going to equal 25. So we'll take our 5x minus 5, set it equal to 25. And we'll take 5x minus 5, set it equal to -25. Okay, so over here, we'll get 5x equals 30. So x is 6. 5x equals minus 20. So x is minus 4. In our second example, we're having to solve this quadratic inequality. So the first step here is always to get a 0 on one side, okay? But before we do that, let's go ahead and square our x minus 5 just so we have that ready to go. So we have x minus 5, x minus 5, x squared minus 5x minus 5x, and 25. Okay, and then notice we're multiplying that by 3. So we'll end up with a 3x squared. Here we would get a minus 10x, but we're going to multiply that by 3, so minus 30x plus 75, because 3 times 25 is 75. Okay, that's going to be greater than or equal to 3x minus 9. Okay, so we want to move that stuff over. So we'll subtract 3x and add 9. So we'll get 3x squared minus 33x plus 84. Oops, that shouldn't be an equal to, that should be a greater than. Okay, one thing I noticed, right now, this looks kind of hard to factor because of our 3x squared. But all of these have a factor of 3 in it, so we can divide each term here by 3. Okay, so that'll simplify our equation just a little bit, so it's a little bit easier to factor. So we'll get x squared minus 11x, and then 84 divided by 3 is 28. So now it's a little bit easier to see how it factors. So we'll have x and x. I see 7 and 4, and we're going to want those both negative. Okay? So either we have x equals 7 or x equals 4. And we have this equal to sign. So when we're plotting this on the number line, we're going to have closed circles at 4 and at 7. Okay? So now we got to figure out which intervals we have. I always like to put in a 0. Okay, we can put that into our original equation and see what we get. Okay, so if we put in a 0 here, we'll get 0 squared minus 11 times 0 plus 28. We're going to end up being positive. Okay, so then the pattern goes negative positive. Okay, well, we're looking, where are we greater or equal to 0? Where are we positive? So we're positive when we're bigger than 7, and we're positive when we're less than 4. Okay, so if we're writing that, we would have x greater than or equal to 7, x less than or equal to 4. Those would be our solutions. Okay, on the next one, we are looking at a graph, and we have to write this in vertex form. So first thing we want to do is identify our vertex. That's our lowest point. That's at 2, 3. Okay, so in our vertex form, we don't have our a yet. That's what we're going to find, but we have x minus our h minus 2 squared plus 3. Okay, if we're wanting to find our a, if we go out 1 from our vertex, notice our scale here, going out 2 grid spaces is actually going out 1 value. We're going up 1.5. Okay, here would be a whole 1. So what we're going out, we would normally go up 1. If we're now going up 1.5, we could see that we're multiplying by that 1.5. That would be our a. Okay, so we have a stretch here. It's not just a normal parabola. Okay, last questions here. We are basically just writing our transformed equation. This is a review from last chapter. So we have a square root function, right? That looked like y equals square root of x, and it's shifted up 3 to the left 2. So we have y equals the square root of x. If we're going left 2, it's inside with the x, but it's a positive 2, plus 3 on the outside to move us up 3. Okay, absolute value equation with a stretch factor of 1.5, that's our a, shifted right 4 and down 5. So we have y equals, well, our stretch factor goes first, absolute value of x right 4, we're going minus 4, and then minus 5. Okay. So if you need a review of these, I know I'm going fast through them, but you need to be looking at your function transformations packet and kind of looking at our general form for each and understanding that our a is always our stretch, the number next to the x moves us left and right, and the number on the outside that's being added or subtracted moves it up or down. Last one is our quadratic. That's talking about a parabola and a y equals x squared. So it's reflected down, and it has a compression of 2/3. So it's talking about our a value. And if we're opening downwards, we know our a value is going to be negative. Okay, so we kind of need to put those two pieces of information together to figure out our a. And then it's shifted left 1 and up 3. So we have y equals negative 2/3. That's our a. X left 1 would be plus 1 squared plus 3. So I hope this video was helpful. I know it might have been a little bit long, but hopefully you were able to skip to the points you need. If you have any questions, please email me, and don't forget that you can use this on your test tomorrow. I'll see you later.